So for number 1, 100 to the 1/2 power, 10 is the correct answer. 10 is the correct answer. 10, 10, 10, 10. Good, y'all figured that out. If you tried that one, you got it correct. Now, if you're not really sure why it's 10, I'm going to show you. So right here, we're going to rewrite this as the square root of 100. And then, well, if I think about 100, it's also the same as 10 times 10. And when you're taking the square root of something, you need 2 copies of it to pull it out of your square root symbol. So this is just equal to 10, and there's nothing left in the square root symbol. So the answer that you're looking for is 10. All right. Let's take a look at the second one now, 50 to the 1/2 power. And this is all just right from Unit 4. So that retest that we had last Wednesday, this was part of that material. It is not 25. So it's not, this does not mean half of 50. If it did mean half of 50, then 25 would be right. But it's, oh, this is close. This is, I think, what we want. But let's see, the steps maybe. This is a great first step here. I like this. Changing it to the square root of 50. So if you're not really sure how to start this one, that's what I would suggest. Changing it to the square root of 50. Because that's what the 1/2 power means. Your index is 2 because it's in the denominator. And when the index is 2 on a radical, we typically don't write it. Now, if I take the square root of 50, I'm going to get a decimal answer. So because it says to simplify, this is implied that we're going to keep our answer exact. So I want to see if there's any factors that I can pull out from 50. And one way to do that is to make a factor tree for 50. So we have 50. And then if I think about numbers that multiply to 50, well, I have 2 and I have 25. So 2 is a prime number, so I'm going to circle it, but 25 is composite, so I'm just going to break 25 up again. 25 is the same as 5 times 5, which are both prime. And so now I know the prime factorization of 50 is just 2 times 5 times 5. So if I write it out that way, maybe I could see a little better what I can do here. If I look for, remember, this is a square root, so there's that invisible index of 2. I need 2 of the same factor to pull it out. Well, I have 2 5s, so I could pull a 5 out of here. But then there's still this 2 kind of hanging out in the square root symbol. So 5 times the square root of 2 is your correct answer. And somebody did have that. But I did want to show a little bit more to show you how to get there. Any questions so far on these? You can ask questions through the Meet, through GoGuardian. You can unmute. Just say it if you're in the class. We're going to look at the last one. Okay, so let's see what we kind of started thinking about this one. It's a fraction, 36 over 81, and it's all to the 1/2 power. So how can we start that guy? This person has 2/3 is the answer. Not really sure how they got to 2/3, but it is correct. 2/3, yes, it is 2/3. Square root of 4/9. Okay, yeah, so this is a pretty good thing that we could, I see what they're doing, but the square root, once you take the square root, you don't have the symbol anymore. So it is 2/3. All right, let me show you how you can get to 2/3 because there are some intermediate steps here. First thing I would do probably is rewrite this as a square root. And it's a big square root. It's the square root of 36/81. But when you take the square root of a fraction, you are allowed to break it up. So I can then switch this to the square root of 36 over the square root of 81. The square root of 36. Well, 36 is the same thing as 6 times 6. 81 is the same thing as 9 times 9. 36 and 81 are what we call perfect squares. They come from squaring integers. And so since I have 2 copies, so 6 I could pull out, 2 copies of 9 I could pull out, then this is going to simplify to 6/9, which then further simplifies to, because I can divide out the common factor between 6 and 9, which is 3. So 2/3. And so some of you had 2/3 as your answer, but this is where it came from, okay? So it didn't just magically show up. There's a thought process behind it. You guys have questions on any of the warm-up problems? We are going to be working with square roots today. How did you get, I do have a question. How did you get 5 times the square root of 2 again? So on the middle problem, 50 is not a perfect square. So if I think about the perfect squares, let's come up here real quick. What perfect squares are, they're squares of integers. So, for example, 1 is a perfect square, 4 is a perfect square, 9, 16, 25, 36. Okay, these are examples of perfect squares because they come from squaring an integer. And if they're not one of these numbers, okay, and so after 36 we would have 49. After 49 would then be 64. So I'm just listing them in order. 50 is not a perfect square because it falls in between 49 and 64. So it's irrational, and I'm just going to rewrite it as factors to see if I can simplify it. So because 50 is equal to 2 times 5 times 5, I can even think of this as 2 times 25 and take the square root of 2 and the square root of 25 and get 5 for the square root of 25. That's another way to think about it. So that's where that came from. A factor tree. So it is just where you write the number that you want to factor at the top. And then you just, it doesn't matter. You think of 2 numbers that multiply to give you that number. You're not really going to get anywhere if you choose 1 in that number. So you want to think of factors besides 1 in itself. I started with 2 and 25. I could have started with 5 and 10 and then got 2 and 5, but you just keep going until you get nothing but primes left. and you circle them as you go. Good questions. All right, I'm gonna go ahead, turn that on in case you're still writing on that slide. There's a lot going on. So the next slide here, this is Unit 5, Lesson 22.1, solving equations by taking square roots. So we're going to be taking more square roots. And your learning goal is that I can solve quadratic equations by taking square roots. So this week, we'll spend today and tomorrow on this pair deck. On Wednesday, we're going to do a quizzes kind of activity to help us with factoring. And then on Thursday, Friday, we're going to learn how to solve equations by completing the square. So today's method does not involve factoring polynomials like we were last week. It's a little bit of a different take on solving quadratic equations. And so when we talk about the square root, well, that's a number that is multiplied to itself to form a product. It's called a square root of that product. And so this is important. Every positive real number has two square roots. Okay, one positive and one negative. For example, if I asked for the square roots of 16, well, 4 would be a square root because 4 times 4 is 16. But also -4 would be a square root because -4 times -4 is also 16. Okay, now in the warm-up, we didn't have to deal with having two answers because of the way it was set up. We already had the square root symbol, and you're not allowed to take the square root of a negative number. You can't pull a negative out. Okay, but with what we're going to do today, you're going to see there'll be two possibilities for your values of x. And this is just some of the properties of radicals, okay, that you can take a radical and break it up as a product of radicals, or if you have a radical and you break it up and it's a fraction, a quotient, you can take the square root of the numerator and the denominator separately. And that's kind of like what we saw in the warm-up. So this first example here is basically how we're going to do these problems. So we have this equation up here, 4x squared minus 5 equals 2. Now, if this was an equation without x squared in it, if that was just a regular old x, you would tackle this the same way you would an equation like that. If I had 4x minus 5 equals 2, the game is to get your variable isolated by doing the same thing to both sides of the equation using inverse operations. That's the same idea here. That's totally the same. So as you go through the steps here, their first thing that they're doing is adding 5 to both sides, which is a logical step because I'm trying to get x by itself. The way they write it out is all in one equation. It's one long equation showing they're adding 5 to both sides. Typically, when I show you guys this, I put it underneath, like plus 5 here and plus 5 here, but it's the same thing. And then simplifying this, we get 4x squared equals 7. From this point here, okay, if you weren't dealing with x squared and it was just 4x equals 7, you would divide both sides by 4 since 4 and x are being multiplied. And that's what they're doing here. We're dividing both sides by 4. So up until the point where we get to x squared isolated equals some number, that's totally stuff that you have done this whole year and previous years, okay? It's just solving two-step equations. But at this point here, now that I have x squared equals some number, well, this is where I can have two possible answers. There's a positive version and a negative version of what I could square to get 1 7/75. So we're going to use the definition of a square root, which means by taking the square root of both sides, this plus minus goes on the outside of the symbol. The squared is now gone off the x, but we have the square root symbol here. And if I use a calculator to approximate what this is equal to, it's about 1 32/100. So this is the most concise, neat way to write the answer. But what this means is what it says here. The approximate solutions of the equation are x is approximately equal to 1 32/100 and x is approximately equal to negative 1 32/100. So that's a lot of words. This is the really short way to write it with just math symbols. Anytime you round, you go from a regular equal sign to the approximately equal to equal sign. It's wavy. All right, so we're going to do a couple examples like this, and then I'm going to have you guys do an example or do a problem on your own. So I'm going to force you to come up to the slide that I'm on. We're going to do this first problem over here. 2x squared minus 8 equals 0. And we're going to solve that equation for x. So this is kind of guiding us through what to do. You have your original equation, 2x squared minus 8 equals x. We're going to add something to both sides. I want to undo subtracting 8. So I'm using the inverse operation of subtraction. We're using addition. So what I'm going to do is add 8 to both sides. And we're going to simplify that. Negative 8 plus 8, that's 0. That was the whole reason why we chose to add 8, because I want it to go away on the left-hand side. So now we just have 2x squared on the left-hand side and 0 plus 8 on the right-hand side, or just 8. Next step here, we're going to divide both sides by something because I'm trying to further get my variable by itself. 2x squared, x squared is being multiplied by 2, so if I want it to go away, I need to divide by 2. Two divided by 2 is 1. That's exactly what we wanted to happen, so we're just left with x squared on the left-hand side. On the right-hand side, 8 divided by 2 is just 4. So up until this point, this is it should be very, very like familiar of solving a two-step equation. We haven't done anything that's crazy yet. This is the new part now. The new part is where we're going to use the definition of a square root, which means instead of x squared equals 4, we're going to rewrite it as x equals positive and negative square root of 4. So that's the new thing right there. That's the definition of the square root. This is what's new. And now we take the square root of 4, which is just 2. And I didn't have to round, okay? 4 was a perfect square, so it's exactly 2 when I take the square root. I don't need the approximately equal to sign. I'm using the regular equal sign. And so what that says, x equals plus minus 2, it means that the solutions of the equation are x equals 2 and x equals negative 2. Right? So if you want to write it in the most concise way possible, that's what this is here. And what that means is that there are 2 solutions for x. And you can check them both, okay? If you were to put 2 where the x is and square it, you get 4. If you were to put negative 2 where the x is and square it, you still get 4. So there's 2 numbers that do work. I'm going to rewrite how I wrote those 2's. I don't know, they just both look really weird. It's a little better. First one still kind of looks like a Z or something. obsessing about that, but that's what the answer is. So do you guys have any questions so far? If you're doing okay, let me see. Nothing in the chat. Nothing through Go Guardian. In classroom, we're good. Make sense? Yeah? Okay. All right, so we're going to do this other one. It's not scaffold for us. It's just given to us as 5x squared minus 9 equals 2. It's just like solving a two-step equation up until you deal with that x squared part. So I'm going to show the steps over here like I normally do, where I write the operation underneath when I'm adding or subtracting something. I prefer to kind of do it that way. It's not any different. It's just a matter of preference. So we're going to start by getting rid of this minus 9. And the opposite of subtracting 9 is adding 9. Whatever you do to the left, you do to the right. Rewrite our equation. Now I have 5x squared. Well, negative 9 plus 9 is 0. Those cancel out. They're gone. Equals 2 plus 9, or 11. And so 5x squared means 5 and x squared are being multiplied. So I'm still trying to get the variable by itself. So I'm going to do the opposite of multiplying by 5, which is to divide by 5. And if I divide by 5 on the left, I better divide by 5 on the right. I divide by 5 is just 1. So I'm left with x squared equals 11/5. Well, now I'm going to use the definition of a square root, because that's the only way to get x by itself. Right now we have x times x, so I'm essentially taking the square root of both sides, which then gives me x equals plus negative, positive, negative, square root of 11 divided by 5. Well, 11 divided by 5, that's not a perfect square. And I can't break that into two perfect squares either. I can't do like the square root of 11 or the square root of 5. That's an irrational number. So what I'm going to want to do is open up a calculator. And I'm going to figure out what is the square root of 11 over 5. So if you're using the Chrome calculator, you would click on the square root symbol, which looks slightly different. It's like the check mark thing, but there's not a line on top, but it is the same. That's a square root symbol here. And then I'm going to put in my fraction of 11 divided by 5, close the parentheses, and hit equals. So I'm going to round this to the nearest hundredth, 1 and 48/100. So x, remember, anytime you round, you have to switch from an equal sign to approximately equal to sign. It should be wavy. You have positive and negative. I already forgot what it was. 1.48. It doesn't say how much to round to, so I'm just rounding to the nearest hundredth because we did that earlier on the last slide. And that's it. Okay, this means there's two answers. Either x is 1 and 48 hundredths or x is negative 1 and 48 hundredths. If you want to type that out so it makes sense, you can do that as well. I'll do that too. I'm gonna have to add in those wiggly equal signs because doesn't really work too well on here. I really type math symbols on Pear Deck, which is not as convenient. So you can always just leave some space and go back and just draw them in.